Hello viewers. In this lecture, we shall consider two important topics: the security, the computer and network security, and virtual LAN, which we call VLAN. We have already discussed various local area network technologies, the wide area network technologies, and internetworking. And we have seen how we have developed the capability for connecting any computer anywhere to another computer anywhere. This is a mixed blessing. Why it is mixed blessing? For an individual user who is sitting in his house, in his room, can wander around the internet, can visit any site anywhere in the world, can acquire wealth of information and knowledge through the internet. So it is lots of fun for an individual user. But for a corporate LAN manager, it is a nightmare, since their computers are connected to the network through internet, and various important documents like marketing plan and various other important information which are online available in the network are facing lots of threat. So the computers and the network has to be secured. So first we shall focus on the various aspects of computer and network security. Then we shall discuss what is virtual LAN, and of course at the end we shall see whether these two topics are interrelated or not. First, let us consider the security. As we know, we want security because the computers and network is connected to other systems, and through that network various types of damage can be done. Let us see what are the security threats that a computer or a network computer faces. The threats can be broadly divided into four types. Number one is interruption. In interruption, suppose you have got your source and this is your destination D. Normally, how will you communicate? This is your source and this is your destination. Maybe through the internet. I am not showing the internet. There is a direct link and communication is taking place from source to the destination. But whenever an interruption occurs, the information is not allowed to reach the destination. It is somewhere obstructed by some unknown agency. For example, your telephone connection is cut, so you cannot reach others, or your hard disk is damaged, you cannot access the information stored in the hard disk. That is the interruption, and we can call it attack on availability. That means the resources which are supposed to be available to you are made unavailable because of this interruption. Second type of threat is interception. In this interception, you have got your source and the destination here. You are able to communicate, but the information is monitored by another agency, another host, and we can call it the attack on confidentiality. You want your information to be confidential, but because of this interception, your information is intercepted and there is attack on confidentiality. This is somewhat similar to wet tapping. telephone tapping or eavesdropping. Eavesdropping, that means the information which you are sending is supposed to be confidential, which is being monitored by a third party, and that is undesirable. This is the second type of threat. Third type of threat is the modification. Modification. In the previous case, there is no modification on the information which is being communicated from source to destination. But in this case, what is happening? The source is receiving the information. I mean, source is sending the information which is being intercepted in between, and another agency then it is modifying it and then sending it to the destination. So we can say that this is attack on integrity. You want that whatever information you are sending should reach in unaltered form to the destination. But because of this modification done by a third party, the integrity of the data is lost and incorrect data is being received by the destination. So this is attack on integrity. The fourth type is fabrication. In fabrication, you have got your source and destination here. There is a third party. The third party is sending something. The source has not sent anything, but a third party is sending something to the destination. So it has received some spurious information or message which has not been sent by some well-known or known source. And this we can call it attack on fabrication, attack on authenticity. The authenticity of the source is now violated in this particular case. In fact, apart from this classification, we can classify the attacks into two types: passive. In the passive attack, the interruption can be considered as, sorry, not interruption, but interception can be considered as a passive attack, where there is no active thing is taking place, only another party is listening what is being sent. On the other hand, the other types of attacks are active in nature, like the interruption, interception, sorry, modification, and the third type, fabrication. These are essentially of active type. Question arises, how we can prevent this attack? The most dominant technique used for security of the computer and the network is encryption and decryption. Let us see how it is being implemented. With the help of encryption, you can perform end-to-end security. The approach can be explained with the help of this diagram. Suppose the sender is sending what is called plain text, is sent by the user, let it be represented by M, and there is a encryption technique E, and after encryption the information is converted into what we can call cheaper text or C. Then at the other end, the information, the cheaper text is converted back by decryption D, and you are getting back the plain text or M. And obviously, if there is a, for encryption purpose, you will require a key, and this is the key management, and this key that is being used here is KE, with the help of which you are doing the encryption. which is managed by the key management system, and at the other end you are also using another key, that is your KD key, that is being used in the destination, and that is used for uh, decryption purpose. And this can be mathematically explained as that C that you are getting is equal to EK encryption that you are performing by using that key K on M. And the other end, this is being sent, that this is the cheaper text information that is being sent to the other side, and the decryption is being performed to get back the original message can be explained by this. M is equal to DK. You are applying this decryption technique by using KD, and you are applying on C, or is equal to DK EK, that is same thing, M, and you are getting back the original message. So the original message, which is plain text, is converted into a cheaper text, and the cheaper text is, and this is being sent through the communication media or the network, and the other end you are performing decryption and getting back the plain text. And actually the effectiveness of this encryption technique is not really decided by the secrecy of the key, but how much effort one has to put to get back the original information, to break the key, to break the code and get back the original information, and that effort has to be very high. And there are basically two approaches. One is known as one key encryption. In this, the key at the transmitting end, key that is being used for encryption and key that is being used for decryption is same, and this is known as symmetric encryption technique. On the other hand, there can be public key or which is called asymmetric encryption technique, in which at the the encryption that is being done at the sender end is done by one key, and at the receiving end it is done by another key. So obviously in this case the key that is being used at the sending end is known, it is public, but the key that is being used by the receiver, that is different, and that is secret. And in the previous case, in one key encryption, which is symmetric encryption, the key is kept secret and only the destination host knows what is the key. That is how it is being used. And usually the key is of 64-bit, and there are various standards. Data encryption standard, which is called DES, and there are some, based on that data encryption standard, keys are decided. So this is how the encryption can be done, and with the help of which end-to-end security can be ensured. However, with the help of this encryption you can achieve end-to-end security. But what about the authentication of the source? We have seen that there is a possibility of fabrication. What can happen? The destination is receiving something which is not correct, or which is not sent by some authenticated source. So to perform message authentication, another technique can be used. Message authentication can be done this can be done to achieve or you can say for active attacks. What is being done in this case? Suppose this is your message. On this message, encryption is done. Actually, some kind of hashing is done, and key is being used, and that message access key, which is derived from the message, this message access key is being sent, and both these two together, the message along with the message access key, these two are sent to the other end, and the other end receives it and after receiving it, the other side also performs the same encryption by using the same key, and these two are being compared. So here is the compare function, the comparison is done, and after comparison, if the message access key, this is message authentication key, authentication code. The what is being converted is message authentication code. This message authentication code, this is a received one and this is the computed one. So these two are compared, and if there is a mismatch, we know that the destination node knows that the information has been received from unknown source, not the desired one. So it has been received from some unauthorized source. This is how the message authentication can be implemented by using encryption technique. And another approach for doing that is secure hash function. Hash function. You can perform hashing on the, your message is variable length, and you can perform hashing to generate fixed length code, and that can be sent to the other end. And the other end, you will apply the same function to generate the fixed length code and then compare and see whether the message has been received correctly or not. So this is how you can do the authentication. Now another problem here is, with the help of this encryption technique, the message in transit can be protected, or you can identify whether you have received correct one or wrong one. You have received from authenticated source or not authenticated source. But how do you protect the information in a single system or in the enterprise network? Which this can be done by using firewall technique. So what you want, this is the old medieval technique. As you know, a ditch is made around the castle so that the other people cannot enter. So the castle is protected by the ditch, or if there is a fire on the other side, it cannot cross the ditch. So this is the basic approach that is being used in firewall technique. This is the firewall, and what you want, this is the rest of the internet. So this is the rest of internet, and all the information should come, or the communication should take place through this firewall, and this is the organization part of the network, organization part of the internet, organization part of the internet. So the communication has to be done through the firewall. What are the building blocks of firewall? How you can create a firewall? Let us try to see. The firewall can be created by using two routers and a gateway, application gateway. So this side we can say is the rest of the internet, and this side is the part of the internet. What these routers and the gateways are doing, let us try to understand. This router, which is connecting the rest of the internet to the firewall, is receiving packets, and it has got a table, and that table, with based on that table, it checks whether a particular message can be accepted or it should be dropped. So based on the policy decided by the managers, and which is implemented using a table, the router decides whether a packet has to be allowed to pass through or it has to be discarded. Similarly, this router, all the traffic which is originating from inside is but it also checks whether a particular message or datagram can be allowed to go out of this internal network, and this is being done by the router. And the table, the typical kind of table that is being used is shown here. This is the outside and this is inside, and the table that is being made is shown here. Let's, in this case, the router has got only two ports. Router has two ports. Port 2 is connected to the outside, port 1 is connected to the inside of the network. And using this table, the filtering is being done. As you can see, port number 1, which is connected to the inside, here the IP source is given, and the protocol that is being used is TCP, and this 25 port number, destination port number, is essentially for email. As you know, this is well-known port number 25. This implies that any email originating from 125.5, and this is for subnetting network, based on TCP protocol should not be allowed to go out. Similarly, the other entries correspond to incoming traffic. Any message that is coming as FTP, telnet, whois, trivial FTP, then finger protocols based on either UDP or TCP should not be allowed to enter the network. That should be dropped. So using this kind of routing, the filtering can be done. Let me draw the same diagram. So the same diagram. This is your corporate network. This security perimeter is essentially physical perimeter. It is well guarded. Nobody can enter, but all the communication is done through this gateway, through this firewall. As I have told, you have got two routers and the application gateway. So we have seen that these two routers performs packet filtering or discarding based on some policy which is implemented using a table. What is the role of this gateway? You may be asking, why do you need a gateway? The purpose of this gateway is that we want these two routers should be on two different networks. That is one purpose. Second purpose is, if we want second level monitoring of the information, that can be done by this gateway. This gateway is a application gateway. That means not only it can look at the IP address, the port numbers, but it can look at the contents of the message. That means suppose somebody is sending spanning tree technique algorithm, but only the port address is used for the purpose of broadcasting over a single group based on IP address. Then the fourth approach is by IP multicast. By using IP multicast technique, the dynamically systems can join a particular group in an affirmative manner or leave a group. So, these are the four possible approaches of membership policy for grouping in a virtual LAN. Now, uh, uh, question is how the various members of the group will be configured. It has to be done fully manually or in a fully automatic manner. There are two situations. Number one is in the beginning, all the hosts are to be grouped, which we may call initialization. Subsequently, moves and changes. If a host moves from one place to another, or if a host wants to change from one group to another group. So, there are three things, and these three things can be configured by using three levels. There are three primary levels. One is manual, in which case all the three cases, initialization, moves and changes, it is done by manual technique. In semi-automated approach, some of the configurations either in the beginning or when changes takes place or when the grouping has to be I mean moving is a particular host moves from one place to another, then semi-automatic approach can be used. That means partly it is done by manually, partly it is done by automatic technique developed by the manager, and finally it can be done in a fully automated manner. In a fully automated manner, a particular host can join a group based on some policy, say based on its IP address or based on a particular person belongs to a account section or purchase section or some other section, based on its work or on IP address. In a fully automated manner, in a dynamic way, the configuration can be done. Then the question arises, how these groupings are communicated between different switches. For that purpose, there are three techniques which are used. One is table maintenance by signaling. Explicit signals are sent for the purpose of table management, maintenance. Then frame tagging. Frame tagging is a technique by which some kind of that header is sent, with the help of which that the switches can communicate it for the purpose of group management. Then time division multiplexing is another technique by which the communication can be done for VLAN membership information. Now, regarding the VLAN has found to be very important, and it is necessary to develop VLAN standard. There are two standards which have been proposed so far. Sometime in 1995, this 802.10, which is essentially a standard for network security. It was the Cisco people thought that why not use the 802.10 technique or frame for the purpose of VLAN, although other members were not agreeable to that. But this is one technique which Cisco suggested. Another standard which is accepted, which was proposed sometime in 1996 by the 802.1 subcommittee. As you know, 802.1 is internetworking subcommittee. They developed a standard which is being accepted widely, And the three important features of this standard is the architectural approach to VLANs. It decides about how the VLAN architecture will be implemented, how multi-vendor devices will be accepted. Normally, because of the non-availability of VLAN standard, it was very difficult to implement VLAN, particularly whenever you are working in a multi-vendor environment. You have computers from different companies, switches from different vendors. In such a situations, in absence of standard, it is very difficult to implement. So in this particular standard, that multi-vendor devices was given a very important focus. Then it suggested future directions. VLAN is emerging, and obviously it cannot be completely defined at this stage. So it gives future directions for subsequent development of the VLAN standard. Now let us consider the various benefits of VLAN. Because of VLAN, virtual LAN, you can reduce the cost of moves and changes. As you have seen, based on the policy, the moves and changes can be fully automated, and so the cost of moves and changes can be reduced. The overhead for moves and changes can be significantly reduced. Groups, the main objectives of VLAN, as I told in the beginning, you can manage virtual workgroups in a very convenient way with the help of VLAN, and it maintains 80-20 rule. What is this 80-20 rule? 80-20 rule says 80% of the traffic is over the members of the group, and only 20% of the traffic is outside the group. So using it, this implementation of VLAN actually helps you to implement this rule. Otherwise, what is happening nowadays, because of the client server paradigm, all the traffic is going to the from all the clients is server directed. So there is a lot of traffic where the servers are concentrated. With the help of VLANs, you can make different groups, and you can try to achieve this 80-20 rule. And with the help of this, you can access local network resources. By using virtual LAN, you have created a logical grouping, which are but the resources can be physically dispersed. But this does not prevent you to access some local resources. That can be done by routing between two different VLANs. Then you can create centralized server farms by using VLAN. Server farm is becoming very popular in present day computing, and VLAN helps you to implement it. And another advantage is the security aspect that I discussed, where we require routers. Using routers, you can implement the security. We have seen how it can be done. The VLAN helps you to create firewalls in a very convenient way. Finally, the deployment of VLAN can be done by using two approaches based on infrastructural based VLAN implementation, or it can be service based VLAN implementation. In the present day context, the service based VLAN implementation is becoming more and more popular. For example, based on the service, accounts, purchase, academic section, and so on, you can group the VLAN, and then it can be implemented that way, and this is becoming more and more popular. Finally, we can conclude by saying that VLAN will be popular only if VLAN implementation solves the real world problems. Only when the real world problems will be solved by VLAN, then it will be more and more attractive. So far it is not that popular, but it will be very popular because of the advantages that I have mentioned. And whenever people will find that it can be useful for solving most of the real world problems, only then it will be more and more popular, and with time definitely it will become popular. Thank you.